Hello everyone. We have reached chapter number 5, a separation of substances. In this chapter, we shall study about the need for separation of substances and the various techniques employed for the separation of components of a mixture. Most of the things around us, like air, milk, rocks, soil, paints, seawater, etc., are mixtures. What exactly is a mixture? Do you know? A mixture is a substance that contains two or more pure substances mixed together in varying proportions. The substances which are mixed to form a mixture are known as its constituents or components. Depending upon the distribution of these components in a mixture, mixtures can be classified into two categories: heterogeneous mixtures and the homogeneous mixtures. Let us first of all discuss about the heterogeneous mixtures. These are the mixtures in which the constituents do not get mixed up uniformly, and each part of the mixture has got different properties. For example, you must have seen a mixture of oil and water. Now tell me what happens when you pour oil on water. Oil, being lighter, forms a separate layer over the water, and you can very clearly and distinctly see the two different layers. Such type of a mixture is known as a heterogeneous mixture. You can see here in this diagram also, there are two colored dots, purple and green, which constitute the heterogeneous mixture. And as you can see in this diagram, the two dots, they are not uniformly mixed together. Now let us discuss about the homogeneous mixtures. Homogeneous mixtures are the exact opposite of the heterogeneous mixtures. These are the mixtures in which constituents are not only uniformly distributed, but each part of the mixture, it shows the same properties as well. For example, if we dissolve salt in water, salt solution is formed. Can you see salt and water separately in a solution? No, you cannot, because salt has distributed itself uniformly all over the water. So such type of a mixture is known as a homogeneous mixture. Can you give me some more examples of heterogeneous and homogeneous mixtures? Now the question arises that what's the need for separation of the constituents from a mixture? There are several reasons. The most important reason is removal of the harmful substances. Sometimes when we buy wheat, rice and pulses from the market, these food grains, they usually contain small pieces of stones and insects. These stones and insects, they are harmful for us. That is why we need to separate them from wheat, rice and pulses before using them. The second reason is to obtain certain useful components. For example, when crude petroleum is dug out of the earth, this crude petroleum, it contains several useful components like petrol, diesel, kerosene, etc. We separate these components of petroleum to obtain these useful components. Now, separation also helps in the removal of certain undesirable substances. For example, you might have seen your mother preparing tea by adding tea leaves, sugar, and milk in the boiling water. What happens after tea is prepared? She separates the tea leaves from tea using a tea strainer. Why does she do this? Can you tell me? Of course, this is done because the used tea leaves have now become undesirable component. So, we separate the components of a mixture to remove undesirable things. In the previous chapter, you have read about the physical properties of various substances. These physical properties, they form the basis for separation. When we want to separate a component of a mixture, we should first find out some of its properties that would be different from the remaining components of a mixture. Now let us study about some simple methods of separation. As you can see in this flow chart, there are different types of mixtures, like mixtures of two solids, mixture of an insoluble solid in a liquid, mixture of a soluble solid in a liquid, mixture of two liquids, mixture of two immiscible liquids. In all these types of mixtures, different types of techniques are employed. For example, when the mixture is of two solids, then the different techniques that can be employed, they are hand picking, threshing, winnowing, sieving, and magnetic separation. However, when the solid is insoluble in a mixture of solid and liquid, then either sedimentation and decantation, loading, filtration, or centrifugation technique can be employed. In today's lecture, we will take up only two types of mixtures, that is mixture of two solids and mixture of an insoluble solid and a liquid. Start with the techniques employed for the separation of solid substances from a mixture of two solids. The first and the very common technique is the hand picking. Hand picking means taking out undesirable components from a mixture by hand. You must have seen your mother or grandmother doing it at home also. When we buy grains and pulses from the market, they sometimes contain undesirable components like small stones. And these components look very different from the food grains. They are of different size and color as well. That is why they can be spotted easily, and such undesirable components can be removed by hand picking. Now, this method is convenient only when the size, shape, and color of unwanted substances is different from the useful ones. If they are similar, then they will be difficult to spot, isn't it? That is why it's very important that they should be of different size, shape, and color. Second thing is that hand picking technique can be employed only when the quantity of the mixture is small. If I give you a gunny bag full of rice and ask you to take out the stones from it, will it be possible for you? Of course not. It will take lots of time. Third thing is that the unwanted substance should be present in smaller quantities. If I give you a gunny bag full of sand and put a handful of rice in it and ask you to separate unwanted substances from it, then will it be possible for you? No, of course not. The second technique is threshing. Threshing is the process of separating grains from the scaly, inedible chaff by beating them on ground or by using machines like thresher or combine. When the grains are harvested, these grains they are covered by a scaly, inedible substance. This inedible substance is known as chaff. On small land holdings, manual threshing is done. The farmer holds a pile of crop in his hand and hits it on a rock or any hard surface. During this process, the grains they separate from the chaff. However, on the large land holdings, it is done very easily with the help of machines called thresher or combine. These machines are very time efficient. The third technique is winnowing. Winnowing is a method of separating heavier and lighter components of a mixture by wind or blowing air. This method is used by farmers for separation of grains from the husk. The grains being heavier fall down, whereas the lighter husk particles are carried away by the wind. Next technique is sieving. Sieving is the method of separating components of a mixture that are different in size by using a sieve. A sieve is a shallow vessel that has small holes in it. You must have seen a sieve at your home also. The size of the holes in the sieve, it depends on the size of the component to be separated. This method is very commonly used at our homes to separate wheat bran from flour. You may have also noticed similar larger sieves being used at building construction sites to separate pebbles and stones from the sand and cement. Magnetic separation technique can also be used for separation of a solid from a mixture of two solids, but it is based upon the physical property that some substances are magnetic in nature while others are non-magnetic. Magnetic substances are the substances like iron, nickel, and cobalt which get attracted by a magnet, whereas non magnetic substances do not get attracted by a magnet. So, if we have a mixture of impurities of magnetic substances in a non magnetic substance, then this technique of magnetic separation can be very easily employed. That's it for today, students. In the next lecture, we will study about the other techniques of separation like sedimentation, decantation, filtration.